Okay, so finding the derivative of this function isn't too difficult, but we want to practice using logarithmic differentiation. So we're going to use that to find the derivative of this function. So remember, the first thing that you do is you get the natural log of both sides. And so here on the left side, I'm going to have natural log of f of x. And then on the right side, I have natural log of, let me use the same color here, so x to the fourth plus 1 squared times 3x minus 5 to the x, all to the fourth. Okay, and so then what you do is you split this up, and remember our fast way to split it up was we bring the exponents down. They're going to come down, and then if the factors are multiplying, that's going to turn into an addition between the logs, and if you're dividing, you subtract. So we don't have any division here. So that was our super fast way. So it's just using all the laws of logarithms at the same time. Okay, so if I'm going to split this up, here I'm going to have the 2 is going to come out in front, and then natural log of this is going to stay the same, x to the fourth plus 1. And then this turns into a plus, so plus, and then the 4 comes down, so 4, and then another natural log of this inside. So I just used 2 of the laws of logarithms in one step. The one that says you can bring the exponents out in front of the log, and the one that says that products turn into addition when you break up the logs. Okay, so once you do that, then the next step is to get the derivative of both sides. Let me go a little to the left. Okay, so I get the derivative of the left side and the derivative of the right side. Okay, so when I get the derivative of the left side, remember that the derivative of natural log is 1 over the inside, which I'm going to leave alone, 1 over f of x, times the derivative of the inside. Well, the derivative of f, I'm just going to write it as f prime of x. Okay, so this is equal to then, here I'm going to have the number 2, and then the derivative of natural log of x to the fourth plus 1. Remember, the derivative of natural log is 1 over the inside, so 1 over x to the fourth plus 1, and then times the derivative of the inside of the natural log by the chain rule. So this would be 4x to the third inside. Okay, and then I have a plus, and then 4, and then 1 over. So notice I'm not putting the 1. That's just because I have this 4 up here already. So if I didn't have a number here, I would put the 1, but I don't really need it. So it's going to be this 4 over 3x minus 5 to the x times the derivative of the inside of the natural log, which is going to be 3 minus, and then the derivative of 5 to the x, remember, is 5 to the x times natural log of 5. Okay, well, great. So then all I have to do, once I do that, is I need to just get rid of this f of x. So I'm just going to multiply both sides by f of x. And remember, f of x is simply the original function that you had. So this f of x is actually this original function right here. So I'm not going to rewrite it, but that's what that is right there. So that's your result. Whoa, crazy. Sorry. Okay, that's it. Okay, so we want to find the derivative of this function. Now notice, though, that we're not using logarithmic differentiation. This is simply a log function, and we're going to get the derivative of it. So if we're going to get the derivative of the log function, the first thing we would want to do is to split it up using the laws of logarithms. So if I want to break this up all in one step, remember products on top turn into addition, and then the division is going to turn into subtraction when I break it up into the three logs. So what I'm going to have is log base 4 of 5x, and then plus, now here I have an exponent. Remember, the exponents go in front, so this is 4 log base 4 of sine of x. And you could have left it alone, but then you avoid having to do the chain rule there more than you already have to. Okay, so then you're going to, so since we're dividing, we're going to subtract this one, and then again, this 4, we're going to bring it over. So 4 log base 4 of x squared minus 1. Okay, so then we can simply get the derivative of it. So again, it's important to realize we're not using logarithmic differentiation, which is where you get the log of both sides, then get the derivative of both sides. Here, we're just getting the derivative, and that's it. So each one of these logs, when we get the derivative of it, we're just going to do 1 over the inside, which is 5x in this case, and then remember times natural log of the base, which is 4. So here, then we multiply times the derivative of the inside, which is going to be 5. And notice you can cancel these out if you want. Okay, and then plus, and then I have 4 over, I'm not going to put the 1 this time, and actually you can remove it from here. But it's 4 over the inside, which is sine of x, and then times the derivative of sine of x, which is cosine of x, and then minus 4 over the inside, which is x squared minus 1, times 2x. And that's it. So for the derivative of this function, you might be thinking, oh, that's easy. It's just e, so the derivative is just itself. But really, it's not just the regular exponential. What you have here is you have a function, e to the x to the fourth minus 3x, and that's being raised to another function. So this is one of the situations that requires logarithmic differentiation. There's no other way to find the derivative of this function than by using logarithmic differentiation. So remember, you start off by getting the natural log of both sides. And the whole point of getting the natural log of both sides is so that you can bring the exponent out in front. So when you do that, we would have natural log of f of x is equal to 5x squared times natural log of e to the x to the fourth minus 3x. Okay, so then we get the derivative of the left side and the right side. And when we get the derivative there, we're going to have to use the product rule here on the right. So on the left side, let's just do that. That's going to be 1 over f of x times f prime of x. And then here, when we do the product rule, we're going to have the derivative of the first, which is going to be 10x, times the second, which is natural log of e to the x to the fourth minus 3x. And plus the first, this time leave it alone, so 5x squared times the derivative of the second. Now, the derivative of the second is going to be 1 over this inside, so e to the x to the fourth minus 3x, times the derivative of that inside. So the derivative now of e raised to a power, remember, is just itself, e to the x to the fourth minus 3x. And then don't forget the chain rule again, times, let me move it a tiny bit more, times the derivative of this inside, which is 4x to the third minus 3. Okay, notice, I mean, we're pretty much done here. We would multiply both sides now by f of x. Sorry, f of x. And then f of x, which is simply my original function right here. But I want you to notice something interesting. I did it on purpose just to see if you guys would notice. These two cancel. They're the same. Notice that you could have, right here, using the laws of logarithms again, brought this, the exponent, down in front. And then you would just have this times natural log of e, which is just 1. So, I don't know. I thought it was more fun to do it the long way, but if you notice that, that would save you a little work.